there guys, this is the level 3 video for Practitioner, so if you were able to get every question correct on the pre-assessment, this is the video you should be watching. Otherwise, make sure you're watching the correct video. Now you still have to complete problem set 1 and problem set 2, so I'll show you the answer keys, but make sure you complete those first and then watch this video. So first off, just as a general recap, we know that an exponent tells us how many times to multiply the base by itself, so in this case my base is 4, so 4 to the third power is 4 times 4 times 4. We know that we have these generally 3 laws of exponents we're focusing on today, which is product of powers, quotient of powers, and zero power laws. Product of powers tells us that when we're multiplying exponents with the same base, you keep the base, add the exponents. Quotient of powers tells us that when we're dividing exponents with the same base, keep the base, subtract the exponents. Now the quotient of powers is the one you have to be a little bit careful on. It's the one where you have to determine, okay, where is my exponent larger, on top or bottom? If the exponent is larger on top, keep the base on top. If the exponent is larger on bottom, keep the base on bottom. Then subtract your exponents. And then the zero power law tells us that anything raised to the zero power is 1, such as 34 to the zero power. Well, that's just 1. Now here's the answer key for problem set 1 that you're supposed to complete on your own. This part you completed in the yet puzzle. This part you should be completing on your own. So once again, if you haven't done that, do it, then check your answers here. And then you can pause the video if you need to. Move on to problem set 2. Problem set 2 you should have also completed before watching this video, so there is a level 2 video that explained how to solve this. So if you need help with the level 2 video, you can click on the level 2 video. It's at the bottom of the resource page. And then here are the answer keys for the column B, which is the one you should have done on your own. If you have any questions over any of these or how I got any of these answers, feel free to ask me during the teacher time. But generally, here's the answer key. And once again, you can pause the video where you need it to be paused. So now that I've shown you the answer key, now we are going to, so let me stop sharing so I can move to my computer. Here we go. So once again, you were a practitioner, so you should have done problem set 1 and 2 first. Click on this video to watch it, then start the prove it activity. So the proof activity is on the same page. If you click on the hyperlink here, it'll take you immediately down here. But what we're going to do here is kind of read this kind of idea, and I'll kind of give you the premise. So generally what we're going to do for the proof activity is kind of practice proofs. So one of the most important math skills that we can gain is the ability to justify our reasoning and prove our solutions to be correct. So it's not enough just to say, this is my answer. It's very important to be able to say, this is how I know it's my answer. And in fact, before we can accept theorems or laws into mathematics, most of our foundational math ideas have to be verified through proofs. So this activity, you'll be beginning practicing writing simple proofs to verify the exponent laws we have been using today are in fact true. So, before we just use these laws, and say, okay, they're true because my teacher told me they're true. Well, I want you to prove to yourself that, oh, okay, that's why it's true. Mathematically, it makes sense. So here's an example. The zero power law. So the zero power law tells us that any real number except 0 when raised to a zero power is equal to 1. Now, as any good mathematician, we want to verify if this is true. As for a class, it seems absurd. Any real number raised to the power of 0 equals 1? Well, if you weren't completely convinced before, I can prove it to you. So here's kind of the proof I'm going to do verbally, so I'm going to explain the same thing here that I do here so you can read this. But generally, it starts with our premise a to the 0 power, where a represents any real number that is not equal to 0. Well, I know that I can rewrite a to the 0 power as a to the 3 minus 3 power, because 3 minus 3 is 0, so I didn't change my equation. It's still technically the same thing. But since I have, subtracting exponents, I know that I can write subtracting exponents as exponents that are being divided. This is my division law of exponents. So typically we've been using the division law of exponents this way. So we start with division, end up with subtraction, but this equal sign goes both ways. So if I start with subtraction, I can rewrite it as it being divided, which is what I did here. So I rewrote a to the third power minus a to the third power as a to the third power over a to the third power. Well, I know anytime you're dividing the same thing over itself, it equals 1. So notice I start with a to the 0 power and I end up with 1. And since equal signs are equivalents, I know a to the 0 power is equal to 1. I proved why this law is true, mathematically. Now I want you to attempt to prove either the multiplication law of exponents or the division law of exponents to be true. Can you do it? Here's some starting points. And you don't necessarily have to use these numbers in particular, and you can go any route you want to. And we'll meet together during your teacher time after the 30 minutes to talk about your proof. But can you prove that a to the third power multiplied by a to the second power is equal to a to the fifth power? And something that may help is expanding these exponents out. Or if you want to, can you prove that a to the third power divided a to the second power is a to the first power? So I will say for both of these, the easiest way to prove it is to expand out. So a to the third power is a times a times a, so that's the hint I'll give you. So watch this video. You can rewatch it if you need to. If you have questions, you can always ask me during the breakout rooms, and I will see you during teacher time.